RAID failure. Imagine you are hiring a team of movers to carry all of your valuable furniture into a new house. If you give all the heavy boxes to just one person and they trip, everything is broken. But if you spread the weight across 5 people and one person falls down, the other 4 can still successfully carry the load. In the world of enterprise computer storage, this exact teamwork concept is called a redundant array of independent disks. When you are studying to troubleshoot storage issues for your CompTIA A+ Core 1 exam, understanding how these drive arrays fail is absolutely critical. This is not just a standard desktop computer losing a few pictures. This is about protecting massive databases and critical corporate servers from catastrophic data loss. To achieve your perfect 900 score, you must understand how these arrays are built, how they break, and the exact steps you must take to repair them without accidentally destroying the company's data yourself. Let us dive into the technical mechanics of how a redundant array of independent disks actually fails. The first thing you must identify is the exact configuration, or level, of the array, because this completely dictates your troubleshooting response. If a server is running a redundant array of independent disks level 0, which is called striping, the data is split evenly across 2 or more drives for maximum speed. However, level 0 offers absolutely no redundancy. If just one single hard drive suffers a mechanical head crash or a motor failure, the entire array is instantly destroyed, and 100% of the data is permanently lost. There is no troubleshooting a level 0 failure other than restoring the files from an external backup. On the other hand, level 1 is called mirroring. In this setup, 2 drives hold the exact same identical data. If one drive completely dies, the array enters what is called a degraded state. The server does not crash, and the users will not even notice a problem, because the storage controller automatically and seamlessly switches to reading from the surviving cloned drive. The most common corporate setup you will encounter on your certification exam is level 5, which is striping with parity. A level 5 array requires a minimum of 3 storage drives. The hardware controller card writes the data across all the disks, but it also writes a special mathematical code called parity. If one physical drive in the server rack suddenly starts making a rhythmic clicking noise and fails, the array becomes degraded. However, because of that mathematical parity code, the controller can look at the surviving drives and instantly calculate the missing data on the fly. This means the server keeps running, but you will notice a severe drop in read and write performance because the central processing unit has to constantly solve those math equations to recreate the missing files. The most dangerous moment in a level 5 array is when it is in this degraded state. If a second drive fails before you replace the first one, the math is broken and the entire array is permanently destroyed. When you are faced with a degraded array, your professional troubleshooting methodology must be extremely precise. First, you must log into the hardware controllers management software to verify exactly which physical drive bay contains the dead disk. You will also look for the physical amber or red light emitting diode on the front of the server chassis. Once you have positively identified the dead drive, you will carefully pull it out of the hot swappable bay while the server is still powered on and running. You then insert a brand new, empty replacement drive of the exact same capacity or larger. The storage controller will detect the new drive and automatically begin the rebuild process. During this rebuild, the controller uses the parity data to slowly rewrite all the missing information onto the new drive. This process puts an enormous amount of stress on the surviving older drives and can take many hours or even days to complete. You must never, under any circumstances, remove another drive or reboot the server during a parity rebuild. Finally, you must be prepared for a scenario where all the physical hard drives are perfectly healthy, but the entire array suddenly vanishes from the operating system. This is a clear symptom of a controller failure. The controller is a physical expansion card plugged into the motherboard that acts as the brain for the entire storage array. If the processor or the cache memory on that specific controller card burns out or short circuits, the computer completely loses its ability to talk to the hard drives. The drives themselves still hold all the data perfectly safe, but the digital bridge is broken. To resolve this, you must power down the server, remove the dead controller card, and replace it with the exact same make and model. The new controller will read the configuration data physically stamped onto the hard drives and successfully import the existing array back into the operating system without losing a single file. By mastering these specific array levels, the delicate rebuild process, and the role of the hardware controller card, you will confidently conquer any enterprise storage questions on your exam.